Welcome back again to our YouTube channel. This is Mathematics with Engineer Apps. Today I have something sweet for you guys, calculus and application of it. The question goes, let's read it together. Uhuru Kenyatta has 1,200 meters of wire to fence 3 sides of his rectangular piece of land, which was raided by Koti Kubwa's and Machungwa's goons. Then the 4th side was not affected during the raid. Find the dimension that will give him the maximum possible area. So let's look at the solution. But before we look at this, if you haven't subscribed, please do so. That is the only way that you can support this channel. Let's go back here. Now we're being told that it has a rectangular piece of land, and then the one side was not affected. That means that one part of it is not going to be fenced. So the only part which are going to be fenced is only the 3 part of it. So what we want to say, let's give this length part of it to be L meters. Then the other width that is remaining here, we're going to give it in terms of L, because we know if it is a rectangular form, then that means the upper part of it, this side also is L. Then we can get this side which is remaining because the other part is not affected. So that means for us to get this width, then we take L plus L, then we minus 1,200 then when we get that. So this width that we want in terms of L is 2L is 1,000. What was the total? 1,200 minus 2L. Because when you take L plus L, that one gives us 2L. Then we minus the total, because when you add this, you add that, and you add that, should give you 1,200. So for you to get W here, in terms of L, then it is 200 minus L. So this part here is 1,200 minus L meters. So area that we are asked is equal to length times width. So our length is L multiplied by the width, which is 1,200 minus 2L minus 2L. This one is area. So when we open up the bracket here, we have A is equal to 1,200 L minus 4L. When you open up the bracket here, you get that. So that is the area that we get in terms of L. But now we told find the dimension. So we want to get L and the width, the dimension of that piece of land. So we know that at any turning point, and please, when you talk about the turning point, then I'm talking about the maximum point, the minimum point, or the point of inflection. All that turning point, the dA, or we normally say that the dy over dx, that means the gradient function at that part is equal to 0. But in this case here, whereby we have area is equal to L minus 4L, then we know that at any maximum, then the dA over the dL is equal to 0. So can we differentiate A with respect with L so that we get the gradient function of that? So when we dA over dL, we get 1,200 minus we get 1,200. Sorry, class, this one should be 4L squared, because L multiplied by 2L. We here, let's do this correction. 1,200 L when open up the bracket, and then this one we get 2L squared, sorry, minus 2L squared, minus 2L squared. So here we have minus 2L squared. So dA over dx, when we differentiate, we get 4L. So at this point, we have just explained that is equal to is equal to 0. So easy, so easy. So 1200 minus 4L is equal to 0. So we have 4L is equal to 1200. Then L is equal to 300. So L is equal to 300. But we are asked find the dimension that will give us the maximum possible area. So that means because since the equation which we have gotten is a linear equation, this is not a quadratic whereby we have the two values of L. This is a linear equation whereby the one that we have gotten is the one which is going to give us the maximum length that Uhuru Kenyatta is the dimension of this Uhuru Kenyatta's piece of land. But now we can test whether 3 is going to give us the maximum. So we can test L, then the dA over dL, then diagrammatic representation. We can do it very fast so that we prove if it is maximum. So we said in our last video that when you are testing the turning point, whether it is maximum or minimum, you take that one there, then you pick the number after it and the number before it. So a number here is 301, a number before this is 299. So can we now replace in the dy over the dl here? So if the dA over dl is 299, then we are going to have 1000, that is 299 multiplied by 4, then we get, that is 36. 36 plus 3, we get 39. That is 8. 8 plus 3 is 11. So we take 1200 minus 1196. Let's do it manually. We get, that is 4. That is 4. This one is 9. That is 0. Actually, that is 4. We get it 4. 4. So this is going to be 4. If the L is equal to 300, then the A over the L is 0. That is obvious. When it is 301, let's take 301 multiplied by 4 here. Then we get 12. Then you take 1200 minus 1004, and you get a negative 4. So this is negative 4. So you can see that this is, if you draw this, then you have that, because this is a positive, then it levels, which is 0, then it goes down. So that one is a maximum point. So that means the dimension which can give us the maximum point, L, will be 300. Then the width of the land is 1200 minus 2L. Minus 2L, and our L is 300. So that is 1200 minus 600, and you get 600 meters. So our length is 300 and our width is 600. Those are the dimensions that we are asked here. That is the end. If you have learned something, please remember to give this video a thumbs up. So you get that you mark there. Thank you so much. Bye-bye.